Hey, good day and welcome to the Prezzo Show. Now I've got an interesting video to show you today on a metal machining process you can carry out in the lathe. This allows you to do complex or compound curves on the metal lathe, and I'm going to use that process to finish off a tool that I made in a previous video. But before I do that, I want to show you these stickers. They were sent to me by Matty. Matty runs a channel and he lives in a beautiful part of Australia called Eden, and he sent me a postcard which I thought was rather unique. And I'm going to put them up on the board. Now Matty does old school machining. He's got a beautiful Cincinnati mill that he's just purchased, and he's got a variety of other machining tools in his workshop. So he's got a shaper, a couple of lathes and a couple of mills now, and I think his channel is worth a look. So I'll put a link in the description below, and certainly check it out. He does some interesting stuff. Let's get this one up on the board. Now, if you're wondering about Matty's credentials, he took third place in the 2020 Toolmaker Challenge for a beautiful boring head that he made. So like I said, he's got some expertise worth checking out. Now, in my last video I made this speed handle for a Kurt style milling vise. Now this is an aluminium casting. It's been powder coated. It has two 15mm sockets, and they're held in place with a combination of Loctite and socket head grub screws. And of course you've already watched that video. What? You didn't? Okay, here's the link. That's alright, we'll wait. There's always someone that doesn't do their homework. Is that how you do that?
Hi, my name's Leo and I'm
Hey, Leo! Go on, talk like a pirate. Go on. Okay, build a boat then. How long are they going to be? What the... Well, that'll be right. These wanky craft beers, you need a bottle opener every time. What? Are we back on? Oh, so what are we doing today? Well, in the last video I fitted this temporary handle. That's really not good enough. It's going to have to go. And I want to replace that with something that's a little bit more befitting of a Bridgeport mill. So let me show you what I have in mind. Now this is a 2D drawing I made when I bought my Bridgeport mill and found that one of these feed handles on the, I think it was the X-axis, was broken off at this point here. And because there was one on the other end of the table, I was able to remove that and take a high quality digital photo of that part against a sort of a neutral background. Now most 3D CAD programs have the ability to import JPEG images onto a sketch plane. And I use Autodesk Inventor, but you can do the same thing in Fusion 360. And once you paste that JPEG image onto the sketch plane, you can scale it. Now in my case, I needed an overall length of 88mm, so I scaled the JPEG up and down until I got it to that size. And then using like a Bezier tool, you can go around and draw that curve with a series of control points. Now it takes a bit of tweaking to get it right, and you only have to draw one of the curves, because when you revolve that into a full 360 degrees, you get the complete part. So here's a look at what I did in Inventor, and you can see the sketch and you can see how it scales. And here is the Bezier curve. I think I might have used a spline tool, I can't recall. But once I've got that 3D model, you can import that into a 2D CAD drawing. And then I was able to offset at 3mm intervals and find all of the dimensions from a datum edge or a datum plane. And I took all of those dimensions and I placed them in a table. And because my lathe on the DRO, it actually measures in diameters rather than radii, I've doubled all of these dimensions in the table over here. So then it was a case of just starting at this end point and then moving whatever interval we'd set it at. I think the first one was 2.25 and all the other ones were 3mm after that. So keeping track with the DRO or your hand wheel, the scale on your hand wheel, you can cut in at various points and create a sort of a staircase effect. So what you end up with is something that looks like this, like a sawtooth, and then using files and a grinder or a belt finisher, you can make all of that into a smooth compound curve. Now, for the speed handle, on the for the vise, so I wanted to be able to make the same shaped handle, the same form, but at 80% of the original size. Now Inventor allows you to create a thing called a derived part. So you import the original part, and then on the way in you can change some parameters. So in my case I wanted to change the overall scale to 80%, and I came up with this 2D drawing here. Now because I'd already done this once, I'd learned a lot in that process, and the way I'm going to do this one is a little bit different the way I did this one here. So in fact I'm going to start at this threaded end. So we're going to create this 16mm long thread at 8mm or M8. We'll do the back chamfer, and then we'll do some turning, some preliminary turning before we start doing the steps. Already ground up some turning tools, so I've got a right hand and a left hand tool, and that's going to allow me to actually start at this point here. So, you know, sounds simple, doesn't it? Well, not really, but you'll see it works. Now, one of my old high school teachers used to say, "Young Mark, if you fail to plan, you plan to fail." Now, he said a lot of other shit too, but applied to this case, he was absolutely correct. So I've planned out my procedure as I go along, and this is going to allow me to remove the bulk of the material and get some data points from which all of the other machining operations can take place. So I'm going to keep this handy next to the lathe, and it's going to allow me to get all this prep done before we even start going anywhere near doing the curve. So let's head over to the lathe. This is a piece of free cutting mild steel, like a leaded alloy steel, and I've already done some preparation on this. So this is the M8 thread, 16mm long, and that will thread into the aluminium cast handle that I've already made. This diameter here is the outside diameter of the largest part of the handle, and down this end here it's slightly narrower. So my first step is going to be to machine away roughly 17mm in length to a diameter of 14.47, and that removes a fair bit of the material. Now at that 14.47 stop, we're going to cut in with a parting tool, and that will produce the narrowest point on that compound curve. Once we get all those points fixed, we can start our moves both left and right to get all of the curves done on this end, and then we can flip it around and do the other end to get the convex curve on the end. Alrighty, let's see if we can screw this up. Alright, so that's our length there, roughly 17, and we'll just keep going now until we're down to our correct diameter. So this is the maximum diameter now at this end of the right hand end of the handle, and this is the point where the curve is going to bottom out, but it's not the correct diameter yet. So I'm going to get a parting tool. I'm going to go in and take that groove to the narrowest diameter for the handle. This is my inverted parting tool I got from Eccentric Engineering. It's a lovely tool, but it works with the lathe running in reverse, and the good thing is that it's less likely to catch. But I must say that parting off is my least favourite operation on the lathe. I'm just using some feeler stock to set the edge of the tool against that shoulder there, and we can zero out our DRO at that point. And I'm using this larger diameter here as my datum. So I've got to cut a total of 11.7 millimeters on the diameter. So once again, set the DRO against this diameter here. Righto, let's see what happens. Alright, well, I sharpened that tool and I lowered the speed. Still can't work out why it chatters so much, but we got there. So the next step is to back chamfer the shoulder here, and then we can start our contour turning. So on my little planning chart, we're actually at this point here, and there's the part in the lathe, and you can see I've done the 30-degree chamfer here now. And slight change of plans. I had originally decided to go from the parting groove to my right and finish all of the curve up to this point here, but it makes it really hard to get the tip of the tool into the bottom of that groove here with all of this stock. So I'm going to actually do all of the cuts from the parting groove to the left-hand end. And when we've got all of this out of the way, we'll be able to get into the bottom of the groove and do the remaining cuts. Now it doesn't look much, but that's my first cut. So that's 0.26 of a millimeter deep, 24 millimeters from the center of that parting groove. And that takes us almost up to the biggest diameter on the handle, and we're just going to keep working our way back now. Alright, so that was probably the deepest cut that I need to make. From now on they're going to get sort of shallower as we get to this lowest point here. And you can sort of see the curve starting to emerge out of that. So let's do a couple more. Well, there's our steps. I'm going to go the other way now. There's a view of it at the moment, and of course the closer you put the steps, the more accurate you're going to fit that curve, and this is going to require a lot more work to get rid of all the steps, but we'll get there in the end. But certainly you could place those at 1mm intervals if you really wanted to. I think we're good. Alright, well, I've cut this off, and this is now about say just under 2mm longer than I actually need it, measured from the end of the M8 thread. I put a very, very shallow countersink in the end of the stock there, because I need to support this with a tailstock while we do the remaining cuts. Now I've also turned up an M8 bush, and that's going to protect the thread, and it's also going to be useful later when we go to blend in this curve, as you'll see. So I'm going to push that all the way in, thread that all the way home, grip that in the 3-jaw. Just make sure we're right up against the jaws there, and then we can just support that with the tailstock center. Now I've zeroed out my tool, so we've got our right hand tool set up. Just do the usual thing with that shim stock and just pinch that, and then we can zero the DRO at that point. and I've zeroed the face of the tool against the end of the stock at this end. And what I need to do then is to move along the distance of the extra stock that I've left on the end of this material here. So I want to get rid of the countersink in the end of that stock there when I'm finished, so that's why I left a little bit extra. Probably could have left more. But the offset that I need to do now is 1.97 millimeters, and then we can zero the DRO at what is like the virtual end of the stock, or the virtual end of the handle when it's finished. So with everything done there, our first cut is going to be made all the way along to the first step, closest to the maximum diameter, and then we'll gradually step back toward this right hand end. Alrighty, that's it. There's a big lump on the end here, but most of that's going to come off, or at least 2 millimeters of that is going to come off, and then we can blend all our curve together, and hopefully we won't see our little countersink in the end of that stock there. Should have planned a bit better, should have had more on there. Anyway, let's get this out now and do the last step. So it's starting to look like a handle. Now at this point you can put the job back in that threaded bush and then put the whole thing back in the chuck, and then contour that and get rid of all of the sharp edges using a combination of files. So for these sections here, the convex sections, you can use a big flat file and just work that over that surface there to remove the sharp edges. On these concave surfaces you can use a half round or whatever shape file you've got that's going to work there. Now that's a fair bit of work and you will get there, but there's a quicker way. Right, this is where that threaded bush comes in handy, and I chose the size of that to allow me to fit it into the drill chuck on my cordless drill. Now you may not have that luxury depending on the part that you're trying to create, but you've got to think of some way of being able to rotate this quickly and then hold it against your belt sander. And this will allow you to quickly contour that, especially this end. That's going to be fairly easy. Getting in here is going to be a bit of a mission, but we'll see how we go. All right, let's stop there and let you have a close look at that, and you can see how that's starting to blend. And we've just got to keep at that until all those little sharp internal corners there are gone. And I'll stop just short of that point and we'll change out to a much finer sanding belt, and then we'll take it down the rest of the way. We're getting very close, at least on about 2/3 of it. This bit back here I'm going to have to put my thinking cap on there to see how we can get that. But I don't know if you noticed, but on this belt sander I've got a section from about here up to the tangent point on the contact wheel where there's no backing support. So I'm keeping the stock in that area there so that as I press it sort of conforms to that shape. We're very close now. I'm going to swap out to the finer belt and we'll get a final contour on this part. I think with this section down here I've got no choice but to put this back in the lathe and try and work on that with the file. Alrighty, nearly done, and you can see I got rid of that little dimple in the end there, got rid of nearly all the marks. There's a couple still here, but let me go back in the lathe and work on this bit, and then we'll give it a final polish. Now this is an inherently difficult and dangerous operation when you're working close to the chuck jaws with a file, and this is a rather unusual file. It's like a half round on both sides with two different radii. It's a really old file. It was actually, I think it belonged to my father. But what we need to do here is to keep complete control of the file. And in terms of grip, when you're holding any sort of tool like this, like a file, your elbow, your wrist, the grip on your hand and the file should form one continuous line so that you've got complete control. And if you are pushing the file forwards, you're doing it from the elbow and the shoulder, not from the wrist. So you basically lock your wrist and keep the file firmly in your grip. Now your left hand should be grabbing onto the tip of the file, and you should be resting your left forearm on the headstock of the lathe. And then with the lathe running, you can slowly lower the file down into position and get to work. Now the most dangerous way to do it is to approach the spinning chuck with the file in one or both hands and have the tip of the file unsupported, because you've only got to wander a little bit and make contact with one of these jaws. Remember, it's spinning that way, it's going to flick the file back at you and either break the file, damage the chuck, hit you in the head. All sorts of bad things can happen. So if you approach the lathe, it's like this: grip the file and then lower it down onto the work. Now you see I'm getting there, I'm very close now. The important thing here is that when you're filing, you keep lifting the file. So you're pushing the file forwards and to the right and lifting it clear, and that way you've got a clear view of what you're doing. If you've got the file covering that area and you're just sort of moving it backwards and forwards, you've got no sort of guidance on how close you are to the bottom of those contours. So just periodically lift it. It also allows the chips to clear out of the teeth of the file. Alright, here's one of the sad realities of polishing metal. The trouble is that the higher the polish, the more it shows up every single scratch and defect. And you think you got it pretty good, and then you start to bring the luster up on it, and then you see all the defects. So a couple of big gouge marks in here, a couple up here, and they're going to need a fair bit of work. So I'm not going to bore you. I'm going to keep working on this, and I'll bring you back when I've got that pretty close to being finished. So I think you can see those scratches there, they're quite deep and just up here. So certainly not happy with that. Alright, that looks wonderful, doesn't it? But I guarantee you there will still be rotary scratches and grooves and marks in that. They're disguised by the marks made by the emery cloth. And if you want to see them, now sand axially, right, along the length of the part, and you will start to see them emerge. And this is the correct way to polish a piece of material. You have to alternate your scratches. First of all, you go around the part, and then you've got to go lengthwise until all of the scratches from the previous abrasive are gone, and then you move up to a finer abrasive. Now, I don't really want a mirror finish on this, but I just wanted to show you that you can be fooled into thinking you've done a wonderful job, and it's really not that good. So He said that, now he can't find his scratches. There'll be some in here. And I can actually see it just here. But like I said, I'm not really bothered about getting a mirror finish on this, but I will give this a bit of a scratch along the length, and then I'll show you the final step in this process. Okay, well you should be able to see all those scratches now run lengthways, and we're going to do the final step on this Scotch-Brite wheel. Now a lot of people asked me about this in my last video. This is about 50 millimeters wide or 2 inches wide, and it was 6 inches in diameter. It's now about 140 millimeters. So what's that? That's about 5 and a bit over 5.5 inches. Damn! Stupid inch measurements. Okay, 5.5 inches. I went looking on eBay because that's where I bought it. I looked on eBay in my purchase history, and unfortunately eBay doesn't keep it for longer than 3 years now. So I can't quite be sure how long I've had this one, but they last forever. Now they're very dense, as you can see there, and they're quite firm and quite hard. Now you can buy a genuine 3M Scotch-Brite wheel which looks like that, but they're very expensive, and I had a look the other night, and the only ones I could get were from the USA. Now this one came from, don't know, wasn't the USA, probably China or Taiwan, somewhere like that. So it could be a knockoff. The label is gone, so I can't even tell you what brand it was. But if you can get hold of one of these, they're the most brilliant thing for deburring, polishing, graining metal. They're absolutely brilliant. Now, they come in different grades too. I can't even tell you what this one is. But let's give it a whirl now and see if we can get a final polish on this. Now, it won't be a mirror finish. We're looking for that satin finish. Alright, I'm going to stop there. There's really no point going any further. It's going to get a bit scuffed and a bit scratched in use anyway. And I think you'll agree that looking at the reflections in that, we've got the contours pretty right. If that had bulges and dips and lumps in it, you'd see it in the reflections that it's showing. So let's get it on the speed handle now and do the glamour shot to finish up. Well, here's the original Bridgeport handle that I copied. Here's the 80% version of that, and you could probably argue that this is really not practical. It would be better to have a center axle and then have a rotating sleeve on that, which was held on with a sort of a flathead screw at the end, so that when you spin it rapidly, it doesn't slip in your hand. It doesn't actually slide over your skin. It would actually rotate around that center axis. But I don't know, I reckon this looks better. I mean, who doesn't love curves? So this is going back on the milling machine now. To all intents and purposes, it's finished. Somebody had mentioned that I should fit some magnets on this so that I can slide it underneath the vise and it'll hold up underneath the vise, and it's out of the way, but it's there if you need it. And somebody has mentioned I should have put my name on it or engraved my name on it or something, but there's not a lot of real estate on there, so I don't know if that's going to happen. I would very much like to, but for now I think we're going to leave it like this. So thanks for watching today. Now I've got a new set of videos coming up, and I can safely say it's going to be at least 7 or 8 episodes. And I'll give you a very, very sneak preview of what we have in mind for that. And then I'm going to say farewell. I'm going to leave you with some wildlife photos today, just some ducks that we saw in the backyard the other day. So this is Prezzo signing out, and I'll catch you on the next video.